Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 14.7, day 1, entitled Introduction to Statistical Thinking. And in this section, we're going to talk about the role of randomness and then different designs of experiments. Now, in statistical thinking, we make judgments about an entire population based on just a sample. So a population consists of all the individuals in a group, and a sample is just the subset of the population. And everybody uses statistical thinking in everyday life, but sometimes it's done incorrectly. So in this section, we're going to investigate the key features of statistical thinking, as well as some common statistical pitfalls. Now, we use samples because it's really challenging to gather information from the entire population. So here it says that a census, which is data obtained from the entire population, it's a better guarantee of correct results, but a census is not necessarily more accurate, because if we had to survey the over 300 million people who live in the United States, it would be very time consuming, it would be very expensive, and there's a greater chance that lots of errors could be made. So if we carefully select a sample, we're going to be more likely to get our accurate results. Now, when the data is collected, it can be done in many different ways. So you can survey or do a survey sample. That's where you answer questions to, or you make responses to a questionnaire. You answer questions on a questionnaire. You can do an observational study where you just collect data by observing. Here they're collecting data on birds and watching birds. You could go to an airport and observe human behavior. And then there's also experimental studies, and this is where you collect data from a certain experiment that you perform. And that could be like taking a new type of drug to see if it will cure you of a certain ailment. Now, when we're dealing with our experiments, we have to make sure that they are random. And this really can't be overemphasized. Your sample has to be random, and that means that it's selected arbitrarily and without bias. That's the key. So everyone has to have the same probability of being selected to be in the sample. Now, we expect a random sample to share approximately the same properties as the population. So that way the sample is as close to the entire population as possible. Now, the larger your sample size, the more closely the sample will approximate those properties of the population. So when you're actually doing data collection and you're doing research, if you're not getting the results that you want, you just keep experimenting and you keep adding more people into your sample. Now, if we want to estimate the average height of adult males, it would be very biased of us to select a sample from the NBA players because they're all tall, or the majority of them are very tall individuals. So that's not going to be a good sample that reflects the height of all males in the country. So non-random samples are generated when there is bias in the selection process. And such samples are useless for statistical purposes because the sample is not representative of the entire population. Now, a simple random sample is one in which every individual in the population has the same probability of being selected. So that's what it means to be truly random. And to satisfy this requirement, the sampling method that is used must be free of bias with respect to the property being measured. And a lottery method of selection produces this simple random sample. Now, there's several different ways that you can generate that lottery sample. One way is a computer generated random list of random numbers, and your calculators will actually do this. You have a random generator on your graphing calculators. And this is where you assign a number to each individual, and then you would use that computer random number generator to select numbers. Okay? So we want to make sure that we're forming a sample that is random and representative of the entire population, but there are some definite types of bias. There's 4 types of bias that we're going to talk about. So we'll take a look at these and then we'll deal with a question and an example about them. So our first type of bias is undercoverage. This is where a certain part of the population is excluded. That would be like saying that you sampled the entire high school population, but you forgot the freshman class. Response bias is where the wording of a questionnaire is not neutral. So it kind of makes you want to answer it in a certain way. Like you would say, we think, or don't you think that we should raise more money for the library? That has definite bias because you want to answer, oh, yes, of course. You want to agree with what the person is saying. A neutral way would say, do you think we should raise more money for the library? And then you could simply answer yes or no. Okay, so we don't want bias when we're trying to get a certain response from someone. Now, non-response bias is different. It doesn't mean that you're not responding. It means that certain individuals are either unwilling to respond or they're completely neglected. So it's not the opposite of response bias. It's its own type of bias. And then we have self-selection. And this is where you're volunteering to take the survey. So a lot of these types of results are based upon convenience sampling. And that's when individuals are sampled only because they're nearby or they're easily accessible. So that's where you would stand outside the McDonald's and ask people questions as they went in and out of McDonald's. Okay? So let's take a look at example 1 here and see if we can identify the different types of bias. And we have 5 parts to this example. So for example, 1 part A here says a political blog conducts an online poll to gauge the approval rating of a candidate for political office. So we have to determine if the sample is random. And if not, identify the type of bias. So this one is actually going to have bias. It's not going to be random. And it's biased because it shows self-selection. The only people who are going to take the online poll are the people who go to that political blog and volunteer themselves to take the survey. They have enough time. They've got nothing else to do. Sure, they'll look at the blog and they'll take the survey. Okay. Part B, to investigate people's performance for different brands of toothpaste, a polling firm selects a random sample of telephone numbers from the telephone directories of several large cities. Sounds good, but it actually has bias as well because it might not get all the cities that use that type of toothpaste. So this is undercoverage. Okay, part C, to investigate the amount of energy drinks consumed by college freshmen, a student stands on a campus sidewalk and interviews willing participants. So this is definitely going to be biased. This is not random. It's undercoverage because, whoops, because not all students, I don't know why the pen's not writing, because not all students would be interviewed, and it also is self-selection. It's only the people who are willing to participate. Okay, so there I got the pen to write. So part C is under coverage and self-selection. Okay, part D now. Here we have a mail survey. Asks people's opinions on the preservation of a wilderness area. Only a small percentage of the surveys were completed and returned, and those mostly favored an increase in wilderness areas. So it sounds nice that they're mailing them out to everyone, but this actually has bias because, again, it's self-selection. Only the people who want to take the survey would actually complete it in the mail and return it. And you could also say that this is non-response because people who are concerned about a wilderness area might not live in the certain place where all of this was mailed to. So you're leaving out other people who might be concerned about the preservation of the wilderness areas. Part E, a survey designed by residents opposed to building a new mall in their neighborhood asks, do you support the building of the mall which will increase traffic and lower property values? So again, this one has bias. And the type of bias is response. Because if you were asked that type of a question, you'd be a little more um, willing to say, oh, yeah, of course I support that if it's going to increase. Oh, I mean, I'm not going to support it if it's going to increase traffic and lower property values. Oh, those are bad. So, a better way to ask that question would be very neutrally, do you support the building of the mall? Okay, so it's this phrase right here where it says it's going to increase traffic and lower property values. Those are bad things. So you don't want to put that into your question because, of course, you're going to get people saying, oh, no, I don't want that. I don't support bad things. Okay, so you're going to see some problems like that in your homework where they'll ask you about the different types of bias. And the next thing we're going to talk about is randomness and the role of randomness in our sampling methods. And we have several methods that have been developed for sampling in particular situations. So there's three that we're going to talk about. Systematic sampling is where a sample is chosen systematically from a list. Like you make a random list and you choose every 100th person or every 5th person. A stratified sample is where the population is first divided into non-overlapping groups, and then the sample is chosen proportionally from each group. So you might have different amounts of people in each group, so you're going to take the same proportion of people for the sample that you have for the entire group. And then the last type is cluster sampling. And in cluster sampling, this is where a population is divided into clusters, and then it's randomly selected. So this is a little bit different from the stratified, because the clusters, here they explain it, is where you would look at people, for example, in certain buildings, in certain apartment buildings, and then you interview certain residents in each building. So they're clustered by their location. Okay. The stratified example they explain here, this is where you're grouping people into their ethnicity. And then you're taking a random sample from each of those. So there's a slight difference in the stratified and the cluster. Okay. And again, we do this type of sampling because it saves us time and it saves us money and it saves us energy. Okay, so let's look at example 2 here and see if we can figure out what type of sampling method is being used. So we're going to have A, B, and C. They're going to give us a scenario and we're going to say what type of sampling method it is. So for part A, to investigate student attitudes about the Big Bang Theory, a researcher first partitions students into class categories, freshmen, sophomore, juniors, and seniors, and then selects a random sample proportional from each group. So that is going to be stratified. So you're grouping them first, and even though you might have different amounts of freshmen, sophomores, juniors, and seniors, you're going to take a proportional amount. So you're not going to take necessarily the same amount unless you have all the same amount of freshmen, sophomores, juniors, and seniors. For Part B, to gauge voter attitudes on an upcoming ballot measure, a pollster selects a sample by starting at an arbitrary name in a list of registered voters and then selecting every 50th voter on the list. So this is going to be systematic. So systematic, you're going to have some sort of rule that helps you select the people. For Part C, to investigate college administrators' attitudes on grading practices, a researcher randomly selects a sample of universities and then interviews all top-level administrators at the selected universities. So this is going to be cluster, as you're grouping them by location, by those universities first, and then you're asking certain people within those universities information that you would need. Okay, so again, you're going to see some problems in your homework like that where they're going to ask you about the different types of sampling methods. Next, we're going to talk about the design of an experiment. And in observational studies, the researcher has no control over the factors affecting the property being studied. The researcher is merely an observer. So here we're talking about observational studies. And extraneous or unintended variables that systematically affect the property being studied are called confounding variables. And such variables are said to confound or mix up the results of the study. So we don't want that. So for example 3 here, let's see if we can think of what some of the confounding variables might be in these situations. So for part A, we're going to discover any relationship between heavy drinking and lung cancer, a researcher selects a random sample of heavy drinkers. Okay, well, the other thing that might cause their lung cancer could be how much they smoke. Okay, so the smoking could be a confounding variable. Also, their genetics. Some people are more prone to cancer than others. So those are just 2 examples of some confounding variables. You might think of others that might also be completely correct. For Part B, to test a gasoline additive that claims to increase gas mileage, a researcher solicits volunteers to test the product in their cars. Okay, sounds good, but it depends on the type of car you have, and it also depends on the condition your car is in. Okay, foreign cars might perform differently than domestic cars. Older cars might perform differently than newer cars. Okay, so those would be confounding variables. Part C here, last one for example 3. A new method of teaching mathematics is advertised to increase student scores on standardized tests. Sounds great. To test this claim, a researcher selects the mathematics classes at a local private school. Well, something that could confound this research could be the teacher's abilities or the teacher's skill set, how capable they are. Are they a good teacher or a bad teacher? Are they very knowledgeable or not? Are they brand new teacher or a veteran teacher? Something else could be student test anxiety. Or how tired the students are when they take the test. Are they hungry? Did they have breakfast? Did they have a fight with their parents or girlfriend or boyfriend right before they took the test. So there's a lot of different variables that could affect the outcome there. Okay, so in your homework, you'll have some questions as well where they'll talk about confounding variables. And remember, that's just anything that could cause the experiment not to go as planned. Okay, now to eliminate or vastly reduce the effects of confounding variables, researchers often conduct experiments so that such variables can be controlled. So now we're going to talk about all the different types of experimental studies that we can have. And in experimental studies, we're going to have two groups. You're going to have a treatment group, which they're given the actual treatment, what is being experimented with. And then there's the control group, and they're the people who are given no treatment. Okay, so you have to have one group that gets no treatment and one group that gets the treatment so you can see if there's a difference between them. And that difference has to be statistically significant as well. The individuals in the experiment are called the subjects, and the goal is to measure the response of the subject to a treatment to see if the treatment has an effect or not. And again, it has to be statistically significant. So the next step is to make sure that the two groups are as similar as possible, except for the treatment. If the two groups are alike except for the treatment, then any statistical difference in response between the groups can be confidently attributed to the treatment. So here are some of the different types of designs that will allow us to do that. And there's 3 of them. So here's the first one, completely randomized design. The effects of unknown variables that may confound the experiment can be reduced or eliminated by randomization, that is, by assigning individuals randomly to the treatment or the control groups. So randomization ensures that the effects of any confounding variables are equally likely to occur in either group. So any difference between the two groups in the response to the treatment can be attributed to the treatment, which is what we want. So you're just going to completely randomly pick people to be in one group or the other. Randomization block design, or randomized block design, is where variables that are known to affect the response can be controlled by blocking. So the participants are arranged into blocks or groups consisting of subjects with similar characteristics, and then the treatment and the control groups are randomly selected from each of those blocks. So for example, if gender is a known source of variability, then a male group and a female group are formed, and then you randomly select a treatment and a control group from the male block and then from the female block. Now, that design is nice because it controls for a known confounding factor. So that could be something like gender or age or even income. So it ensures that equal participation of individuals from each block get assigned to the treatment and the control groups. Now, the last type of experimental design that we're going to talk about is our matched pair. And in this design, the subjects are matched in pairs based on variables that affect the response to the treatment. So for example, the subjects of the study may be matched in pairs based on age and gender, a young male with a young male, a senior female with a senior female, and so on. Then an individual from each pair is assigned one to the treatment group and one to the control group. So that way each group has equal participation with respect to the two possible confounding factors or confounding variables. Now there's one other terminology or piece of terminology that we're going to talk about, and that's the placebo effect. And this is really kind of cool and really important. It's very real. And this is when patients think they are receiving medication and they report an improvement, but they're really not being given any treatment at all. They're being given a placebo or a fake treatment. So if you were being given a certain medication, the treatment group would get that medication, But you can't have the control group not getting anything because then they know that they're in the control group. So you have to give them some sort of medication as well. So you give them a placebo, a fake medication. So if it was in a pill form, you would give the treatment group the medication in the pill form, and then the control group, you would give them a pill, but it would just be a fake pill, like a sugar pill is what they call it, where it's not going to have any effect on your body whatsoever. But the placebo effect is when people are given that placebo, that sugar pill, and then they think that they're getting the treatment, so then they start to feel better. So it's all psychological. So to control the placebo effect, researchers have to use single blind or double blind methods. Single blind is where the subjects don't know which group they're in. Double blind is the best because this is where the subjects and the experimenters don't know who's in which group. Okay? And then replication, remember, is when you can repeat the experiment. So when you're doing an experiment and you get statistically significant results, either good or bad, other people are going to look at your results and your experiment and they're going to see if they can replicate it. And if they can replicate it and get the same results, it validates your research. If they replicate it and get different results, then you have to do more experimentation. So replication is a key factor in all of this type of experiments as well. So last example here, example 4. We're going to test the effectiveness of a new flu vaccine, and researchers are going to conduct a study with 800 individuals, 500 women and 300 men. The subjects are to be assigned to treatment and control groups. So we're going to suggest different experimental designs for this study. Now, if I just had to answer it my own way, I would say you want it to be double blind. You don't want the participants to know which group they're in, and you don't want the researchers to know who's in the groups either. Because sometimes the researchers can give subtle hints or clues to the participants. So if the researcher comes every day to give you your treatment or to give you the flu vaccine, they could, use body language or a tone in their voice and let you know if you're actually getting the flu vaccine or not. So we don't want any of that to confound the research either. So we want it to be double blind. That's the best. And then I would say that we would need to do a randomized, oh, why does that stop writing? Randomized block. So we would need to put the individuals into probably a male and a female group, and then randomly pick women from the women group and men from the men group. So that way you have a treatment and a control group that has about the same amount of women and men that's proportional to the amount you have here. Okay, so that would be my answer. Here's some of the other options. Let's see. We suggest 3 possible designs here, or the book does. In each design, the subject in the treatment group are given the vaccine, and those in the control group are given the placebo, of course. To further unbias the procedure in the experiment, we suggest double blind. Okay. And then they've got some different options here. They say you could do completely randomized design. So that's where you would assign 400 patients to the treatment group and 400 to the control group. Okay. Randomized block, that's the one I talked about, where you would block them into a male and a female group, and then you would pick a certain representation to be in the treatment or the control. And you could also have a matched pair design, which the book describes here. So you could match them so that you have age and gender. So you would have an old man matched with another old man, and then one would go in the treatment and one would go in the control. So there's lots of different ways that you can form an experiment. You just have to make sure that you're reducing as much bias and as much confounding variables as possible. So this type of homework isn't so much calculating, it's more reading and thinking and writing out your answers and making sure that you're understanding these concepts that apply to statistics. So not a lot of homework, but definitely go through it and ask questions on it because sometimes this terminology is very similar and it's easily confused. So come on in before school and see me if you have questions.